Hey, just for you to know, in case it's needed. So yesterday I disconnected the panel. So it's disconnected. The panel is outside. It's not plugged in. So what happened was the circuit was running through the battery and through the LEDs, and it didn't discharge anything. So it's like 1 amp, almost 1 amp. This one is getting 12.8. So it's boosting to 80. This one, the 36 volt, is charged. This one also is charged, 81, 80. And here is 12.9. This one is 12.9. And from the LED lights, it's 13.3. And the lights were running all night, as you can see on the small little box, just to get the volts. So this, I think this can confirm that it maintains the battery, because the battery yesterday was 13 point something, now it's 12.9. I know. And the loads, I mean, these LED lights are being, I'm gonna show you the LED lights, because it's not just one row, it's 2 rows, but I haven't put LEDs on the other side yet. I mean, I haven't put the solar panel yet. I'm gonna build a similar panel as this. This one is 12 cells, 5 volts, and this one was built like this. These are silicone wires, just to be more malleable and easy to work with. But the thing is that the loads from last Victron, from here, is going through their mass over there, and it's powering this joule TIF. This one I had to remove during the night because it's from the lights, but during the day I turn on all of them, so it's turned on. So the lights were running through 3.3 volts all night, but I'm getting the 40 volts from the panel. This is 13 because of the battery, but the battery almost didn't discharge at all, as you can see, and less than 1 amp steady, and the rest is filled.
Okay, so that's coming from the solar there, and it keeps fluctuating between DC and AC, and as you can see, it's blinking. Okay, now this is the battery, which is coming from this controlling the solar in the box. Okay, now that is being charged by the inverter over here, from here, which is connected to the battery right there. Okay, which is running everything, from here. This controller here, you can see. Then this controller here. It was going down until I fixed it and it stabilized at 11.9, because it was at like 12 or 13.1, and then I was doing things and it decharged, and then I finally got it to stabilize at 11.9. And so right now everything seems to be stabilized, except this here, trying to prevent it from blinking like that, because normally I guess I got to get another battery that's much larger to keep it from blinking like that and give it some consistent energy. But for the most part, things are working. Oh, let me show you here. Okay. It's upside down, but
amperages are almost exactly the same within a half a volt. I've seen people blow diodes, I've seen people catch wires on fire, all kinds of bad stuff when they started mixing panels together. It's not generally a good idea. Remember also, when you do that, your system's always going to work at its lowest denominator. So if I could tie these Canadian solars together with those, these would actually be pulled down to those power levels. So then these would be like making no power, and it would be hurting you more than helping you. So that's some of the reasons for having multiple charge controllers. Okay, so now how do you wire multiple charge controllers?
Okay, I don't have all the pieces here. I'm just going to run through this because I don't have a battery. But I do want to show you that I too, when I first started out, had 12 volt lights. So I bought this little gadget that takes 5 volts to 12 volts, and that's hooked into my batteries. That's how the light is on. I will disconnect it, which I did, and reconnect it if I can, and the lights come back on. So we have 16.4. Normally I get 17, but like I said, these are very, very old. Okay, so let's do one more test. Let's take this off, okay, and see the lights that's inside. This is what it looks like. There's the two sides wrapped around the board. You can see the ends here. Okay, this is a foam board or foam core. Let's take the light here. Let's see here. Let me put this on the stand so I can actually show you what's going on here. Come on, cooperate with me. I know you don't want to. Okay, that should give you the angle, and I'll plug it in, and let's see, and there's my lights. They are super bright, and they're on both sides. So as you can see, they really light up the room. Here in Laos, in my hotel room. Okay, so this is what's sandwiched inside the solar panels. So now that you know what that looks like, and again, so we can now hook this back up. Here's the cord to the solar panels. You'll see the solar panel light up again, and that's lit up. And what do we have? 1652, a little bit higher than we had the first time. Again, it should be giving me 17. But now let's go to how this will be hooked up. So we have our solar panel. Okay, let's see if we can zoom out here. And our solar panel is going to be hooked to our charge controller. And we need our MOSFET. Okay, let's see if I can get that into the frame here. Okay. And we have a capacitor if you want to even get more amps. The book explains how that works. And when you hook a battery, which I don't have here in Laos, that wasn't going to let me get through the airport with a lead acid battery in my bag. So the battery will hook to the charge controller, and this, let's see if this will be hooked to the battery. Okay, so let's put that in the picture. So that would be to your battery, the ends of that. Now, how this will run. Let's see if we can get this hooked up. So you can see, this is the battery charger that has pass-through charging. That means if I hook this up, what you see the lights over here, then simulating this, because I don't have a battery, I plug this in. See me plug that in? So both of the charge port here and the part that gives the lights, which if I see how the lights go out, push it back in, so you know that goes to the lights. And once everything is running with the MOSFET circuit going to the thing that I did in the diagram, you take this, because you have full power from the battery, and plug it into the battery here, and that keeps the battery charged. Okay, so again, I can do a full demonstration once I get a battery, get it all hooked up with the MOSFET. This is one of my bigger MOSFETs. This is a very powerful MOSFET, if you can see. It's a giant size. If I look at a regular MOSFET, let's see if I can get that into focus here. Come on, you can do it. Come on, camera. Let's take this down so we can actually get this in focus. Okay, you see where it says 49 amps, 55 volts. Now, with that, put this back on the stand. Let's open this package we just read. And that is the size of the MOSFET. Let's compare them. Put an oversized. Matter of fact, I'm going to take this off because this doesn't want to focus, so you can see it clearly. And this little MOSFET right here, again, puts out 49 amps when it's fully at its peak. But we don't need to run it at 49 amps because we want this little guy to stay cool. So we only do 1 or 2 amps. 5 amps at most. This guy stays cool. This guy right here puts out way more. And the whole point is that you get your heat sink, put these on your heat sink, and keep them nice and cool. Okay, and that's that part. Again, you follow the book instructions. It tells you how to use your capacitors. And I think I showed you everything. Oh, except one thing. Was unhook this and we'll put this back on here. These are the 5-watt panels. Let's open them up, and you'll know that they're 5 watts because they'll have a USB. So if I take the USB, plug them in, you'll see that they light up and they run directly from this power things, and they are as bright, let's see if I can unroll, as the other ones. Okay, now 5 watts to me are not as bright as the 12 watts, but this is a shorter length. This means this rope light is shorter than the 12 volts, means that these are double the length. Okay, so I think I showed you everything. Ask me any questions if you need to, and I'm here to help.
So there's no light, and I'm getting the 75 volts, and using this small flashlight it's going to 100, so we don't need much. The idea is to now get the amps. Yeah, this is what the panel alone is giving me, so I just unplugged it and put it like this, and the panel, the amp panel, which is just a sample just to test if the circuit works properly, it's giving me 0 to 5, so 256 milliamps, which is 0 to amps. And if I increase, I think that if I put I think 7, because this one is 6 and then another 6, but if I put 7 and another 7, I can raise it to 3. I can raise it to 0.3 amps. So the diodes are very important. So as you can see, I get 4. If I use 1, I only get like 0.01, but then if I add more, I get more amps. But the volts are there and the amps are there, so this is a confirmation, and soon I will try and use the diodes that Lloyd said. I'm just waiting for the material to arrive. Okay, so I'm playing around with a couple diodes. As you can see, these are the 2810. These are the Mur 460. This one is a big one from the solar panels, and I'm getting 0.246 amps. So it's the maximum that I can get from the panel. This is the maximum that I can get from these panels. So what I need to do is build a bigger one for the current, for the amps, and I'm sure this one will catch up. So now that I need to see what's the volts, if I'm getting any volts. No volts. So this is the issue that I'm facing, but sooner or later I will fix it.